Hello. So in this video, let us discuss how to represent a graph using adjacency list. So adjacency list is one of the most widely method to represent a graph. So we can represent any type of graph. So here for our consideration, let us use a weighted directed graph. So here we can see that there are many vertices are being used here. And there are totally 6 vertices are there from V0 to V5 identified. So we can see that V0 for V0 the neighbor is V1, and for again for V0 V5 is also a neighbor edge. So it is having a weight of 5, and also on the other side it's having a weight of 2. Similarly, if you look into it for a V5, there are two edges are going out of V5. So one is to V4 with a weight of 8, other one is to the V2 with a weight of 1. So like this, if we look at the graph, we can derive some informations and which we can make use for our representations. Now, this is in a paper and a pencil method, but how to translate this information into first method for implementation, and also to represent in Python programming. So what do we do here? Now we use actually two major blocks over here. So one block is called a graph. One such block is called a graph. So the graph consists of many details. So very particularly, the graph is going to have the list of vertices of a graph. So for a given graph, if you look into it, there are totally 6 vertices are there, starting from V0, and it goes up to V5. So totally there are 6 vertices are there. So in the graph, it's going to simply consist of only the vertices. And not only that, it also each vertex is pointing to a corresponding vertex object. Each vertex is pointing to the corresponding vertex object. And this vertex object is also going to be used. This vertex object will have the details about the key value or the ID of the vertex, and also the neighbors to the vertex with the key and the value information. Okay. So for an example, if you look into it for a V0, as I told you already, the neighbors are V1 and V5. So the neighbors are V1 and V5. And to V1, no, it is having a weight of 5. So having a weight of 5. And for V5, it's having a weight of 2. So like this, we can represent every object as a vertex. So now the vertices in the graph is pointing to or is associated to these vertexes. So if you do it in this way, the system can understand that, yes, these are the vertices that we have used in a graph. And for each vertex, these are this is the ID and these are the neighbors. So like that, the system can easily understand it. So now let us look into the detail about how to implement a Python program for developing an adjacency list, or for representing a graph using an adjacency list. Okay. So the first, we'll understand already. We have understood the concept. Once again, we have replicated here. The two major blocks are the one is called a graph. Other one is called a set of objects called the vertex objects. So we are going to create both, and we are going to interconnect these two so that the graph can be represented. So first we have a class called a graph class. So the graph class is just going to maintain a kind of data structure which can store the vertex, and also which will be able to pointing to the corresponding vertex object. And each vertex object will have the neighbors details and also the ID. That is what we're going to do. So in the constructor, we have defined a constructor. The constructor is not taking any argument. It uses one dictionary called vertices. So by using vertices dictionary, we can maintain the collection of the vertexes. Okay, so now if you look into it in a Python, you know that the dictionary is having two important parameters. One is key and other one is called a value. So it's a data structure which associates value to the corresponding keys. So now this is what actually we have called vertices. So the vertices is going to be a dictionary, and this is going to consist of the vertex objects like V0 and the corresponding V0 object. Corresponding V0 object. When I say V0 object, it is going to have the ID value and also it's going to have the neighbor details. Similarly for V1 and similarly for V2, V3, for all the vertex, it's going to be there. Okay. Yes. That's a main use of the constructor part. And next, if you look into it, we have some more, kind of housekeeping functions. So the housekeeping functions are to load the values onto these objects, these class and objects. So first method what we have is called a add underscore vertex method. So using add underscore vertex method, we can fill in this dictionary. We will fill in with this dictionary. Okay. So for this, we pass vertex object. Vertex object. What is vertex? I'll tell you when I discuss the second class. Vertex object here. Now, if this is a dictionary and the key value will be the vertex object, got it? So this is going to be the key, and whatever the object that we created, we're going to create with the help of the ID and also the adjacency list. Okay, so that will be connected to this V1 by associating the vertex object to the key value. That's for adding vertex. Also, we can use the get underscore vertex to get the vertex details, right? So vertex details, how do we able to get it? So by passing the key value, but by passing the key value, we will be able to get it. How are you going to get it? So we have a condition over here. If the key is there in this dictionary, and it will return the vertices of key. The dictionary, that corresponding value will be returned. Good. So that will be the vertex. And if it is not there, if the given key is not there, then it's going to return the nothing. So it's return none. And the next method is called a kind of a magical function that we are using, which is called a contain function, and it is taking one argument called a key, and it checks whether it is having a key in the self dot vertices. If it is there, it says it is going to be true. And this contain method is mainly used to overload this in operator. So in operator is basically used to check the membership of a particular value or an object in a given iterable. So similarly, in order to use it for a dictionary, it is overloaded here. And the next one is adding edge, right? So once you get a graph, what we need to add an edge. So when you add an edge, we will get the neighbors also easily. So now here add edge, it's using three arguments. One is called a from key, other one is called a to key, then third one is weight. So first we should ensure that whether from key is available in the dictionary. So we check it. From key not in this vertices. Then what you have to do, you call the add vertex and pass this argument the vertex from key, and as one new object will be created, that object will be given to this add underscore vertex. Similarly, the to key is also going to be checked. If it is not there, then it is going to add the two vertex also onto the vertices, because that must be there. In the list of vertices, we must have all the list of vertex and the vertices of the graph. So if it is not there, then it should be added, and newly it can be added. Once it gets newly added, then what we can do, we can call the add underscore neighbor function, which we are going to discuss shortly in the another class. So using this, what we can do, we can set it for the neighbor. For the corresponding vertex, we can set the neighbor. So how? By calling the add underscore neighbor method, which is going to come out soon. Next, there are get underscore vertices member function, which is used to get only the vertices. So from where we will get the vertices? From all the keys. It's going to get the vertices. So that is going to be written. And also we have one more method called iter. It is to iter through the complete dictionary for the values. So by using iter, it automatically gets incremented and it will give us the values at the output. So this is the implementation of a graph class. Also, we have another class which is needed for us, and the graph is also going to be used inside the next class, which is called vertex. So each of this block is going to be implemented in the vertex class. So this vertex class consists of two attributes. One is called ID, other one is the neighboring details. Okay, so we define a constructor here, which is having key and the neighbors. The neighbors also, if you look into it in what form, we have a key and value method. So we will define one dictionary for the maintaining a neighbors. Okay. So now we have a housekeeping functions over there. What are the housekeeping functions? First, we add a neighbor. If you want to add a neighbor, that is what this is the function that we called actually earlier. Add underscore neighbor. So add underscore neighbor takes the neighbor one and also what is the weight? Also the weight. So for this neighbors dictionary, whatever the neighbor that we pass, that's going to act as a key, and the weight what will be given, that will be taken as a value. Okay. So like this, the add underscore neighbor can be implemented and used. Then there is another method called a string method, which is used to customize our print statement. So we want to print the output by using the format method, which is helpful for us to implement a C style of printing the output. So where we wherever we have the flower brackets, the corresponding value that we are going to get, that's going to be printed here in the respective positions. The self.key will be there, and the x.key value will be coming up here. Okay. And the next method is also, it's called as get connections. So what are the connections of the given graph can also be obtained by using the keys of the neighbor dictionary. By using the keys of the neighbor dictionary. So keys of the neighbor dictionary will give us how the particular vertex it's connected to the other subsequent neighbors, subsequent vertices as a neighbors. By use the help of the keys, we'll be able to get it. So that's about get underscore connection. And also similarly, we can get the get underscore weight. Get underscore weight also, it is there in the dictionary, neighbors next dictionary. So from here, we will be able to get fetch of the values. If we fetch the values, then you'll be able to get all the neighbors. Okay. So that's a get in this particularly the get underscore weight will be able to get it. So that's how we define the program in Python. That's a graph in Python. Now we go for another set of implementation. Here I'll show you how this is going to be used here. This already we have discussed. Now I'll come to this one where we have, So both the programs I kept it parallel. Now, in order to make use of this class and objects, we have defined one dictionary over here. We have defined a dictionary. This dictionary is called, sorry, not a dictionary, an object. An object is defined, which is called a graph. So graph is a class, and for which we create an object called G. So all the operations that we are going to do for the graph class will be done through G. Okay, so now here, since we have an access to graph even from using the from import module, then we can use it here even in the vertex class also. So now what do? We create the vertex with an ID of I, and the value of I is basically the value that we are going to generate using this for loop. So from 0 to x, whatever the value is there, that's going to be passed here. That's going to be passed here. So 0, 1, 2, 3, 4, 5 will be the vertex values. Then also what do we do? No, we know the graph. So we try to give information by passing the from edge, from vertex to vertex and the weight. So for a no vertex 0, 1 and 5 are the neighbors. And for 0, again 5 and 2 are the neighbors, 0 to 5. And 2 is the weight. Okay, 0 is the from vertex and 1 is the to vertex and 5 is the weight. Similarly, 0 is the starting node and fifth to 5 is the ending node, and it's going to have a weight of 2. Similarly, we can have for all the edges. Once it is done, however we want to get the print statement, you can customize. Already we have customized here. Already we have customized here all the print statements. So based on this, the print statement is going to be printed on the screen. Okay. So now quickly let us run this and check it out how it's going to work. So I'm running this program. As I run this program, you would be able to see from here to till this place. From here to here, it's basically a dictionary, isn't it? It's basically a dictionary, that a vertices dictionary, where we have the details of the vertex and also the neighbors and also the neighbors. So here we have the details for 0 vertex and what is the corresponding vertex. This vertex object will consist of the important factor like key and neighbors over there. Then also we will be able to get, as per the program what we have written, we will be able to get the connections. So here we'll be able to see 0 is connected to 1 and also 0 is connected to 5. Similarly, 1 is connected to 2 and 2 is also connected to 3. 3 and also connected to 4. And similarly, if you look at the way 5 is connected to 4 and also 5 is connected to 2. So now the graph is, very easily it's implemented, and it is the connections also can be derived from the program. So this gives the exact implementation of the given graph. Okay. Thank you.